All right, so the warm-up for today is a word problem based off of a situation that could happen in football. It says a football is thrown by a quarterback, follows a path given by h of x is equal to negative 2 over 225x squared plus 4/5 x plus 7, where h is the height of the ball in feet and x is the horizontal distance the ball has traveled in feet. If a player can jump at most 11 feet to catch or knock down the ball, at what distances from the quarterback can the ball be caught or knocked down? Draw a diagram and give your answer in interval notation. So we'll start with an x and y. We know that you're throwing a ball. So we have the shape of our graph is going to look something like this. The ball starts up here, comes out this way, and then ends up hitting the ground. Okay? There's some bad information that I've drawn here. Okay? I can't start from behind. I have to start from where I threw the ball. So anything back here is not good, and anything below the x-axis is not good because you can't throw a ball and it go underground. So we need to make sure that we understand that we're stuck in quadrant 1. Okay, so we have restrictions on these graphs. The next graph that's coming out is at most 11 feet. So that means that you can't jump higher than 11 feet, but at 11 feet, you can stop this ball, or you can catch it. So somewhere over here at 11 feet, we're looking at this. It's not drawn completely parallel, but we get the idea. So what I care about are these intersections right here and this intercept right there, along with the y-intercept that's right there. So I have 4 points that I need to worry about. So in my calculator, to find the y-intercept, you hit menu, 510, enter, and it gives you 0, 7 as this coordinate point. If I find the intersection of these two graphs, I've got the first one, which is menu 6, 4 in your calculator. You go to the left and right, and you're going to get 5.31, comma 11. And then all the way over on this side, you're going to get 84.7, comma 11. And then when you find the y-intercept, or the x-intercept, you're going to hit menu 6, 1, select the appropriate graph and go to the left and right and find that coordinate point, which is 98, comma 0. So then once I've drawn this thing out, I need to figure out which part I care about. So if I'm looking at this in a situation, I'm trying to knock down the ball. If I'm over here trying to knock down the ball, it's over my head. So anything that's above this line is not anything that can be touched or caught or knocked down. So I care about what's happening over here in this area. And I also care about what's happening over here in this area all the way down. So in order to show that, I have to do interval notation with all the x values to see which one works. So basically, I'm doing this in my calculator. I've got my first function, f1 is equal to negative 2 over 225x squared plus 4 over 5x plus 7. And then f2 in your calculator was just 11. And we were looking at which one was lower, when was this graph lower than this graph, and we're creating an inequality. So my final answer here is going to go from 0 to 5.31. I'm going to use hard brackets because I can include 0 and 5.31. There's a gap between my answers, so you have to use the union. And then we're going from 84.7 all the way out to 98 with hard brackets, because that's where the ball starts and stops. It can't go any further than that. It travels this distance, and then it goes overhead, and then comes back down to where it can be caught, and then where it hits the ground completely. That takes care of our question. That is our answer in interval notation. We remember that this back part is not good either, because we're only stuck to the first quadrant. And that takes care of your warm-up for today.